Chapter 4. Multiples and Factors. Multiples. Let us revise the multiplication table of 5. 5 multiplied by 1 is equal to 5. 5 into 1 is equal to 5. 5 multiplied by 2 is equal to 10. 5 into 2 is equal to 10. 5 multiplied by 3 is equal to 15. 5 into 3 is equal to 15. 5 multiplied by 4 is equal to 20. 5 into 4 is equal to 20. 5 multiplied by 5 is equal to 25. 5 into 5 is equal to 25. 5 multiplied by 6 is equal to 30. 5 into 6 is equal to 30. 5 multiplied by 7 is equal to 35. 5 into 7 is equal to 35. 5 multiplied by 8 is equal to 40. 5 into 8 is equal to 40. 5 multiplied by 9 is equal to 45. 5 into 9 is equal to 45. 5 multiplied by 10 is equal to 50. 5 into 10 is equal to 50. The numbers 5, 10, 15, 20, and so on are obtained on multiplying 5 by 1, 2, 3, 4, 5, and so on respectively. The numbers 5, 10, 15, 20 are called the multiples of 5. Multiples of 8, 8, 16, 24, 32, 40. Multiples of 10, 10, 20, 30, 40, 50. Multiples of 15, 15, 30, 45, 60, 75. If we multiply a number by 1, 2, 3, 4, we get the multiple of that number. Properties of multiples. Every number is a multiple of 1 and a multiple of itself. The smallest first multiple of a number is the number itself. Every multiple of a number is equal to or greater than the number. The multiples of a number are endless. Thus, there is no greatest multiple of a number. The multiples of 2 are called even numbers, and the numbers which are not multiples of 2 are called odd numbers. Remember, the multiples of even numbers are always even. The multiples of odd numbers can be either odd or even. Finding multiples. To find the multiples of a number, multiply it by 1, 2, 3, 4, and so on. Example 1. Find the first 5 multiples of 5. Solution. 5 into 1 is equal to 5. 5 into 2 is equal to 10. 5 into 3 is equal to 15. 5 into 4 is equal to 20. 5 into 5 is equal to 25. Thus, first 5 multiples of 5 are 5, 10, 15, 20, and 25. Example 2. Find the first 6 even multiples of 4. Solution. 4 into 2 is equal to 8. 4 into 4 is equal to 16. 4 into 6 is equal to 24. 4 into 8 is equal to 32. 4 into 10 is equal to 40. Thus, first 6 even multiples of 4 are 8, 16, 24, 32, 40, and 48. Example 3. Find the first 4 odd multiples of 7. 7 into 1 is equal to 7. 7 into 3 is equal to 21. 7 into 5 is equal to 35. 7 into 7 is equal to 49. Thus, first 4 odd multiples of 7 are 7, 21, 35, and 49. Factors. 6 into 8 is equal to 48. 48 is a multiple of 6 and 8. 6 and 8 are the factors of 48. 2 into 5 into 7 is equal to 70. 70 is a multiple of 2, 5, and 7. 2, 5, and 7 are the factors of 70. Similarly, 8, 9 are the factors of 72 because 8 into 9 is equal to 72. 2, 3, 5 are the factors of 30 because 2 into 3 into 5 is equal to 30. When we multiply any 2 or more numbers, we get a product. The product is a multiple of each of the numbers multiplied, and each number is a factor of the product. Properties of factors. 1 is a factor of all numbers. 1 is the smallest factor of a number. A number is a factor of itself. A number itself is the greatest factor of itself. The factor of a number is smaller than or equal to the number. Every number has at least 2 factors, that is 1 and itself. The number 1 is an exception. Finding factors. Example 4. Is 5 a factor of 75? Thus, yes, 5 is a factor of 75. Example 5. Write all the factors of 12. Thus, the factors of 12 are 1, 2, 3, 4, 6, and 12. Divisibility rules. Divisibility rules help you to find if a number is completely divisible by another number without actually dividing. For example, 72 is divisible by 9 since remainder is 0. 35 is not divisible by 6 since remainder is not 0. Test of divisibility by 2. Condition: a number is divisible by 2 if its last digit is even or 0. Example: 1442, 1980, 1560, 396, etc. are divisible by 2. 3. A number is divisible by 3 if the sum of its digits is divisible by 3. In 3540, 3 plus 5 plus 4 plus 0 is equal to 12, which is divisible by 3. 8262 also divisible by 3. 4. A number is divisible by 4 if the number formed by its last two digits is multiple of 4, or divisible by 4. 79,812, 864, 5068, 12,34,596, etc. 5. A number is divisible by 5 if the digit at its unit place is either 5 or 0. 3,450, 12,345, 56,000, 5,67,890, 99,995, etc. 6. A number is divisible by 6 if the number is divisible by 2 and 3. 750, 7,710, 5,922, 60,606, 11,514, etc. 7. A number is divisible by 7 if the difference between twice the last digit and the number formed by other digits is either 0 or a multiple of 7. 2,975, 1,617, 392, 889. Consider 889, last digit is equal to 9. Now 88 minus 18 is equal to 70. Hence, 889 is divisible by 7. 8. A number is divisible by 8 if the number formed by its last three digits is divisible by 8. 9,89,232. The number 232 is divisible by 8. 18,39,608. 18 lakh, 4,264. 15 lakh, 16,024, etc. 9. A number is divisible by 9 if the sum of its digits is divisible by 9. 9,801, 50,436, 12 lakh, 3,453, 91,917, etc. 10. A number is divisible by 10 if the last digit, that is the digit at units place, is 0. 990, 15,340, 63,990, 1 lakh, 1,020, etc. 11. A number is divisible by 11 if the difference between the sums of its alternate digits is 0 or a multiple of 11. 7,931. 7 plus 3 is equal to 10. 9 plus 1 is equal to 10. Since 10 minus 10 is equal to 0, therefore 7,931 is divisible by 11. 27,896. 1 lakh 35,795, 1 lakh 86,294, 11 lakh 11,110. Prime and composite numbers. Aman has written all the factors of the numbers from 1 to 15 in the table on the left. Help him color the boxes to show the factors in the number grid on the right. Number 1. Factors 1. 2, 1, 2, 3, 1, 3, 4, 1, 2, 4, 5, 1, 5, 6, 1, 2, 3, 6, 7, 1, 7, 8, 1, 2, 4, 8, 9, 1, 3, 9, 10, 1, 2, 5, 10, 1, 2, 5, 10, 11, 1, 11, 12, 1, 2, 3, 4, 6, 12, 13, 1, 13, 14, 1, 2, 7, 14, 15, 1, 3, 5, 15. Number with only two factors, that is, 1 and the number itself, are called prime numbers. Numbers with 3 or more factors are called composite numbers. We observe that the number 1 has only one factor, that is 1. 2 has two factors, that is 1 and 2. 6 has 4 factors, that is 1, 2, 3 and 6. Remember, the number 1 is unique. It has only one factor, that is 1. So 1 is neither prime nor composite. Prime numbers between 1 and 100. About 230 BC, a Greek mathematician, Eratosthenes, developed a method of finding prime numbers. This method is called the sieve of Eratosthenes. Look at this number grid. Cross out 1, leave 2 as it is prime, cross out all the other even numbers, leave 3 as it is prime, cross out all the other multiples of 3, leave 5, cross out all the other multiples of 5, leave 7, cross out all the other multiples of 7, circle all the numbers which are left, find out how many left numbers are not crossed out. In all, odd numbers are not crossed out. These are prime numbers. The prime numbers in the first row are 2, 3, 5 and 7. Even and odd numbers. Every even composite number can be expressed as the sum of two prime numbers. A number which is a multiple of 2 is called an even number. A number which is not multiple of 2 is called an odd number. In other words, odd numbers are not exactly divisible by 2. Even composite number. 4. Sum of two prime numbers, 2 plus 2, 6, 3 plus 3, 8, 5 plus 3. Remember, 2 is the only even prime number. Express the following even composite numbers as the sum of two prime numbers. Prime factorization. All composite numbers can be expressed as a product of their prime factors. 12, 2 into 6, 2 into 3. 12 is equal to 2 into 2 into 3. 20, 2 into 10, 2 into 5. 20 is equal to 2 into 2 into 5. 27, 3 into 9, 3 into 3. 27 is equal to 3 into 3 into 3. Composite numbers 12, 20, 27. Prime factors 2, 2, 3, 2, 2, 5. I repeat 3, 3, 3. A factorization having each factor as prime is called the prime factorization of the number. Prime factorization method. Factorization by division method. Example, find the prime factorization of 56 by the division method. Solution. Write 56 as shown. Steps. 1. Divide 56 by the smallest prime factor, that is 2. 56 divided by 2 is equal to 28. Write 28 as quotient below line as shown. Divide 28 by the smallest prime factor, that is 2. 28 divided by 2 is equal to 14. 3. Divide 14 by the smallest prime factor, 14 divided by 2 is equal to 7. 4. Since 7 is a prime factor, no further factorization is required. Thus, the prime factorization of 56 is 2 into 2 into 2 into 7. Factorization by factor tree method. Example, find the prime factorization of 48 using the factor tree method. Solution. Steps. 1. We know that 48 is a composite number. Divide 48 by the smallest prime factor, that is 2. 48 divided by 2 is equal to 24. So we get the pair 2 and 24. 2. 24 is also a composite number. Divide it by the smallest prime number, that is 2. 24 divided by 2 is equal to 12. So we get the pair of 2 and 12. 3. Similarly, 12 divided by 2 is equal to 6. We get the pair of 2 and 6. 4. Again, 6 divided by 2 is equal to 3. We get the pair of prime numbers 2 and 3. Therefore, the prime factorization of 48 is 2 into 2 into 2 into 2 into 3. Highest common factor, HCF. The HCF of two or more numbers is the greatest number that is a factor of the given numbers. Properties of highest common factor. The HCF of two or more numbers is their greatest common factor. The HCF of given numbers cannot be greater than the numbers themselves. If one number is a factor of another number, the smaller number is the HCF of the two numbers. For example, in the case of 3 and 15, 3 is a factor of 15, so the HCF of 3 and 15 is 3. If the HCF of two numbers is 1, they are called co-prime numbers. For example, the HCF of 13 and 19 is 1, so 13 and 19 are co-prime numbers or co-primes. Consecutive numbers are always co-prime. For example, 4 and 5 are co-prime numbers, and so are 9 and 10. How to obtain highest common factor. Example 8. Find the HCF of 12 and 18. The factors of 12 are 1, 2, 3, 4, 6, and 12. The factors of 18 are 1, 2, 3, 6, 9, and 18. Factors of 12, 1, 2, 3, 4, 6, 12. Factors of 18, 1, 2, 3, 6, 9, 18. The common factors of 12 and 18 are 1, 2, 3, and 6. The highest common factor HCF of 12 and 18 is 6. Thus, HCF of 12 and 18 is equal to 6. Check if both 12 and 18 are divisible by 6. 12 and 18 are completely divisible by 6. Finding the HCF factor method. Example 9. Find the HCF of 8 and 20 using the factor method. Factors of 8. 1 into 8, 2 into 4. Factors of 20. 1 into 20, 2 into 10, 4 into 5. Factors of 8 is equal to 1, 2, 4, 8. Factors of 20 is equal to 1, 2, 4, 5, 10, 20. Common factors is equal to 1, 2, 4. So HCF is equal to 4. Therefore, the HCF of 8 and 20 is 4. Prime factorization method. Example 10. Find the HCF of 18, 27, and 33 using the prime factorization method. Let us find the prime factors of each number. 18 is equal to 2 into 9 is equal to 2 into 3 into 3. 27 is equal to 3 into 9 is equal to 3 into 3 into 3. 33 is equal to 3 into 11. Thus, the HCF of 18, 27, and 33 is example 11. Find the HCF of 24, 36, and 48. Solution. Given numbers are 24, 36, and 48. First, factorize them as follows. 24 is equal to 2 into 2 into 2 into 3. 36 is equal to 2 into 2 into 3 into 3. 48 is equal to 2 into 2 into 2 into 2 into 3. The common factors of 24, 36, and 48 are 2, 2, and 3. Hence, HCF of 24, 36, and 48 is equal to 2 into 2 into 3 is equal to 12. Long division method. Example 12. Find the HCF of 375 and 825. Solution. The smaller number is 375, so divide 825 by 375. The remainder after the first division is 75, so in the second division, 75 is the divisor and 375, that is the first divisor, is the dividend. After the second division, the remainder is 0. The last divisor is 75. Thus 75 is the HCF of 375 and 825. Example 13. Find the HCF of 35 and 49 by the long division method. Step 1. Divide the bigger number 49 by the smaller number 35. Step 2. The remainder 14 becomes the new divisor and the previous divisor 35 becomes the new dividend. Divide again. Step 3. Continue till you get the remainder 0. Step 4. The last divisor 7 is the HCF. Thus the HCF of 35 and 49 is 7. Lowest common multiple, LCM. The lowest common multiple, LCM of two or more numbers, is the smallest multiple among all their multiples that can be divided by those numbers without leaving a remainder. Properties of LCM. The LCM of two or more numbers is their smallest common multiple. The LCM of two or more numbers is the smallest number that is completely divisible by each of the numbers. For example, the LCM of 8 and 6 is 24. 24 is completely divisible by 8 and 6. The LCM of two or more number cannot be less than the numbers themselves. If one number is a factor of the other, the greater number is the LCM. For example, in the case of 3 and 15, 3 is a factor of 15, so the LCM of 3 and 15 is 15. Understanding LCM. Let us see the multiples of 2 and 3 on the number line. Multiples of 2. 2, 4, 6, 8, 10, 12, 14. Multiples of 3. 3, 6, 9, 12, 15. Common multiples of 2 and 3 are 6. Common multiples of 2 and 3 are 6, 12. Among the common multiples, the smallest multiple is 6. The LCM or lowest common multiple of 2 and 3 is 6. Finding the LCM. Prime factorization method. Example 12. Find the LCM of 28 and 30 using the prime factorization method. 28 is equal to 2 into 14 is equal to 2 into 2 into 7. 28 is equal to 2 into 2 into 7. 30 is equal to 2 into 3 into 5. LCM is equal to 2 into 2 into 3 into 5 into 7 is equal to 420. 30 is equal to 2 into 15 is equal to 2 into 3 into 5. Step 1. Write the prime factors of 28 and 30. Step 2. Circle the common factors. Step 3. Multiply the common factors only once and the factors that are not common. Thus, the LCM of 28 and 30 is 420. Example 13. Find the LCM of 10, 15 and 18 by the prime factorization method. 10 is equal to 2 into 5. 10 is equal to 2 into 5. LCM is equal to 2 into 5 into 3 into 3 is equal to 90. 15 is equal to 3 into 5. 15 is equal to 5 into 3. 18 is equal to 2 into 9 is equal to 2 into 3 into 3. 18 is equal to 2 into 3 into 3. LCM is equal to 2 into 5 into 3 into 3 is equal to 90. Thus, the LCM of 10, 15 and 18 is 90. Short division method. This is a quicker method for finding LCM. Example 14. Find the LCM of 8 and 12. Step 1. Divide by the common prime factor and write the quotient below the numbers. If a number cannot be divided exactly, copy the number. Step 2. Continue dividing by common prime factors, writing the quotient below the number. Step 3. Stop when there is no common prime factor. LCM is equal to 2 into 2 into 2 into 3 is equal to 24. Thus, the LCM of 8 and 12 is 24. Example 15. Find the LCM of 12, 16 and 12 and 24. LCM is equal to 2 into 2 into 2 into 2 into 3 is equal to 48. Thus, the LCM of 12, 16 and 24 is 40. Problems on HCF and LCM. Example 16. Find the lowest number which is exactly divisible by 15 and 26. Solution. We find the LCM of 15 and 30 to get the required number. We have 15 is equal to 3 into 5 and 20 is equal to 2 into 2 into 5. LCM of 15 and 20 is equal to 2 into 2 into 3 into 5 is equal to 60. Hence, 60 is the lowest number which is exactly divisible by 15 and 20. Example 17. Two wires of length 18 meter and 24 meter each. The wires have to be cut into small pieces of same length. What can be the maximum length of each piece? Solution. To find the maximum length of the piece, we find the HCF of 18 and 24. Factors. Factors of 18 is equal to 1, 2, 3, 6, 9, 18. Factors of 24 is equal to 1, 2, 3, 4, 6, 8, 12, 24. The common factors of 18 and 24 is equal to 1, 2, 3, 6. The HCF of 18 and 24 is equal to 6. Therefore, the maximum length of each piece will be 6 meter. Example 18. Find the lowest number which, when divided by 6, 8 and 12, leaves 3, a remainder in each case. Solution. We have 6 is equal to 2 into 3, 8 is equal to 2 into 2 into 2, and 12 is equal to 2 into 2 into 3. The LCM of 6, 8 and is equal to 2 into 2 into 2 into 3 is equal to 24. Now the required number is equal to 24 plus 3 is equal to 27. Hence, 27 is the lowest number which when divided by 6, 8 and 12 leaves 3 as remainder in each case.